All right, so here's the Unit 6 radical review number 2. Let's review a couple of things first before we get started here. Number 1, simplify all radicals. As soon as you see a radical, simplify it. What do I mean by that? Well, no factor under the radical can be a perfect square. So find the prime factors, start pulling out pairs. No fractions can be under the radical sign, so I can't like have the square root of 1/2. You have to simplify that. And no radical can be in the denominator, so I can't end a problem with, like, for example, 3 over radical 2. This might help out. If you can take the square root of a number right away, if you see a perfect square, go ahead and take the square root of it. We'll talk about that in just a minute. Number 2, when you're adding and subtracting, you've got pluses and minuses in here, right? Well, simplify the radicals first. If you can simplify, remember that goes back up to number 1, right? Simplify all radicals. But when you're adding and subtracting, simplify the radical first. You can only combine like terms. When you're multiplying, multiply the numbers outside, multiply the numbers inside, and simplify the result. Again, we'll talk about that in just a few minutes. When you are dividing, reduce your fractions first. Anything that's outside the radical signs, reduce them. Anything that's inside the radicals, reduce them. Reduce those fractions. And then when necessary, rationalize the denominator. So let's go back to our test, our practice test, and see how we can do this. Well, like I was saying before, we need to simplify this radical. And if you can take the square root of a number, do it. Square root of 64 is 8. Now, not the square root of 8. You don't keep once you take the square root of a number, there's no more radical sign. The square root of 64 is 8. The square root of 24. How can I simplify that? Well, if you to plug that into your calculator, you wouldn't get a nice round number, meaning 24 is not a perfect square. So what we need to do is find the prime factors of 24. The prime factors of 24 are 2 times 2 times 2 times 3. At this point, we're going to pull out pairs. If there's a pair of factors that are the same, you can pull one out. These guys stay behind in the radical. 2 radical 6 would be your answer. In number 3. Now this 2 stays in the problem. We need to find the prime factors of 48x. The prime factors of 48x are 2 times 2 times 2 times 2 times 3, and then we have the x. Well, this 2 stays out. This one is already out. Then I'm going to pull out a 2. I'm going to be able to pull out another 2. This 3 and this x stay behind. Final answer, 2 times 2 is 4 times 2 is 8, radical 3x. Number 4, can you take the square root of 225? Yes, it's 15. Can you take the square root of x to the 4th? Yes. You take half of the exponent, x squared. There's no more radical sign here. 32. The square root of 32. Well, I need 5 2's. The prime factors of 32 is 2 times 2 times 2 times 2 times 2. X to the 10th. Now, instead of writing out 7 y's, I'm going to just take one away and make it y to the 6 times y. The reason why I do that is because when we take the square root of a variable raised to an exponent, all I have to do is take half of that exponent. Well, I can't take half of 7, but I can take half of 6. So instead of writing y to the 7th, I'm going to write y to the 6 times y. So now I can start taking the square roots of these things. I have a pair of 2's. write one down. I can take out another 2. The square root of x to the 10th is x to the 5th. That comes out. The square root of y to the 6th is y to the 3rd. That comes out. This 2 stays back. This y stays back. So my result would be then 4x to the 5th, y to the 3rd, radical 2y. How would you simplify radical 300x? Y to the 5th is z to the 4th. All right. We need the prime factors of 300. 2 times 2 times 3 times 5 times 5. We have x. Again, instead of writing out 5y's, which I could write out 5y's, but I'm just going to write out y to the 4th times y and then z to the 4th. See, I can simplify all of these. I'm going to be able to pull out a 2. The 3 stays behind because it doesn't have a partner, times 5. The x stays behind because it doesn't have a partner. Y to the 4th becomes y squared. Take half of the exponent. This y stays behind. I'll have z to the 2nd. 4 divided by 2 is 2. What stays behind? I have the 3, the x, and the y. Simplifying the result, 10, 2 times 5, 10, y squared, z squared, radical 3xy. Number 7, fraction. Can you reduce that fraction? 2/5. No, you can't. So what we're going to do is break it up, radical 2 over radical 5. And the reason why I want to do that is so that I can rationalize the denominator. Whatever the radical is in the denominator, take it over itself. Now, what I'm looking at here is I see 2 parts of the problem here. I see a numerator. I see a denominator. Let's simplify each of these one at a time. In the numerator, you have radical 2 times radical 5. What do you do with these two numbers? Right, you multiply them and you'll get radical 10. Then in the denominator, look at it. Radical 5 times radical 5 is what? Radical 25. And what's the square root of 25? So you have a 5 in the denominator. Your answer is radical 10 over 5. In number 8, can you reduce this fraction? Yes, you can. This is actually one big radical sign, x over x to the 5th. Well, how do you reduce x over x to the 5th? Well, keep in mind that x to the 5th means you have your x times x times x times x times x. You have 1 in the numerator that will cancel out one of them in the denominator, so you actually have x to the 4th in the denominator. Let's clean this up a little bit. The x in the numerator canceled out. You still have a 1. One of the x's in the denominator canceled out. You have x to the 4th. And now we can take the square root of this. What's the square root of 1? Obviously 1. What's the square root of x to the 4th? It'll be x squared, half of the exponent. There's your final answer. In number 9, remember, reduce all fractions. See, I can take the square root of 60 over 12 and just write it like this, one fraction. And what is 60 over 12? Well, it's 5. So you end up with the square root of 5, and that's all I can do with that problem. We're done. I'm looking at 2 in the numerator and a 4 in the denominator. But I also have the square root of 84 over the square root of 21, which means I can reduce that. What is 84 divided by 21? 4. So in the numerator, I'm going to have the square root of 4. Well, what is the square root of 4? 2. In the denominator, there's still a 4. 4 over 4, 1. In number 11, now you're multiplying two radicals. Parentheses next to a parentheses means you're going to be multiplying. And what do we do here? Numbers outside get multiplied together. Negative 4 times 2 is negative 8. Numbers inside get multiplied together. 20 times 80 is 160. Are we done here? No, because now I need to find the prime factors of 160. So I'm going to have negative 8 times the radical, 2 times 2 times 2 times 2 times 2 times 5. The negative 8 stays in your problem, remember. It's times this 2 times this 2 that we pull out. This 2 and this 5 stay back. So outside the radical, I have negative 8 times 2, negative 16, negative 32. Inside the radical, I have radical 10. In number 27, two radicals. Multiply those two numbers. I have the square root of 81. Well, there we go. What's the square root of 81? It's 9. Page 2. In number 13, again, you're multiplying here. Well, make sure you multiply the numbers outside and that you multiply the numbers inside. Outside, we have negative 6 times 2. That's negative 12. Inside, we have 5x to the third times 10x. So that's going to be, inside the radical, 5 times 10 is 50. X to the third times x, you add their exponents, x to the fourth. Prime factors, negative 12. 50, the prime factors are 2 times 5 times 5. X to the fourth, you have 4 x's. Because remember, now we can start pulling out pairs. Keep the negative 12 out, it's already there. Pull out a 5. This 2 stays back. I get to pull out an x, and I get to pull out another x. Remember that radical 2 stays back. Negative 12 times 5 is negative 60. X times x is x squared. Those are the numbers that are outside. Inside, I have a radical 2. Here's your final answer. In number 14, we're adding radicals here, but we can only add like terms, right? Never in my life have I ever seen somebody take radical 20 and radical 45 and get radical 65. You cannot do that. You cannot combine the numbers underneath the radical sign. They'll never be added together. What we can do is simplify radical 20. And we've talked about this one several times in class. Do you remember what that is? 2 radical 5. Plus, now we need to simplify radical 45. Do you remember what that is? That'll be 3 radical 5. And then radical 40. It's 2 radical 10. Now, only the radical 5s can be combined. I have 2 of them here, 3 of them here. 2 plus 3, 5 radical 5s minus 2 radical 10. The radical 5 and the radical 10 cannot be combined. That's your final answer. Now be careful on number 15. See, what we're doing, remember, what we're doing is we're adding coefficients. Remember, when you're adding and subtracting, you can only combine like terms by combining their coefficients. You add or subtract coefficients here. So in number 15, we have to know what the coefficients are. Well, in this one, it's going to be minus 5. That's a negative 5. The negative 5 is in front of that 3x. But what we're missing sometimes is the fact that there is a 1 in front of that one. And when there's no coefficient that you see, it's going to be 1. So what we're doing is we're taking 1 minus 5, negative 4 radical 3x. In number 16, we have a number outside and two terms inside. A term outside, radical 5x, and the two terms inside. Automatically, when you see this pattern, a number outside and more than one inside, the parentheses, you're going to be using that's right, the distributive property. So we're going to take radical 5x, and it's going to be taken times radical 8. Bring down the plus sign. Then it's that same radical 5x times radical 5. So here's your plus sign. Let's take a look at this. Radical 5x times radical 8 would be radical 40x. Simplify that. 2 on the outside, radical 10x, plus radical 5 times 5, 25x. Square root of 25 is 5. This radical x stays behind. 2 radical 10x plus 5 radical x. Now, why can't these guys be combined? Because this is a radical 10x. This is just radical x. They're two different things. They cannot be combined. Look at number 17. We're going to be taking 3 radical 3 times radical 6x minus 3 radical 3 minus 4 radical 12. I said that wrong, sorry. 3 radical 3 times 4 radical 12. Let's take a look at this one. Because all we're doing is we're simplifying this radical right here. I have a 3 on the outside and radical 18x on the inside. But that radical 18 can be simplified. Here's the 3 that we already have out. Radical 18 is 3 radical 2, so I'm going to have 3 radical 2x, 9 radical 2x. Minus 3 times 4, 12. 3 times, because we're multiplying here. All this is being multiplied here, right? So radical 3 times 12 is 36. What is the square root of 36? Well, it's 6. 12 times 6, 72, so minus 72. Some of you may, if you're watching this and you're not in my class, you might look at number 18 a little bit differently than the way I taught it. The way I taught it is what I call window panes. I'm probably the only person in the world who's ever done that. I don't know of anybody else. What I'll do is I'll draw a box. With window panes. And because see, what I have here is a binomial times a binomial. There's 2 terms in the first, 2 terms in the second. A lot of you might be using FOIL, but I'm going to write radical 3 here and then negative 5 here. I'm taking this first binomial, radical 3, and then minus 5. And then the second radical, I'm going to do radical 3 and positive 5. Now this first box here, I multiply the 2 given numbers, radical 3 times radical 3, which is 3. And then in this box, the top right, I'm going to be taking negative 5 times radical 3, which is negative 5 radical 3. In the lower left box is going to be radical 3 times 5, so 5 times radical 3. And in the bottom right box, I'm going to be taking negative 5 times 5, which is negative 25. And now, all we're going to do is combine like terms. 3 minus 25, negative 22. These two boxes can be added together because they're like terms, and they're going to cancel because I have a negative 5 radical 3 and a positive 5 radical 3. So my answer is just simply negative 22. Let's try it again on number 19. Draw your window panes. Radical 3, positive 8, radical 6, and negative 1. Radical 6 times radical 3 is radical 18. 3 radical 2. 8 radical 6. Can't be combined. Can't be simplified. Negative 1 times radical 3 is just negative radical 3. 8 times negative 1 is just simply negative 8. Combine like terms. Well, there are no like terms, so you're just going to list these in whatever order. 3 radical 2 plus, it's a positive 8 radical 6. It's a minus radical 3, and it's minus 8, and that would be your final answer. In number 20, I'm going to take this radical 12 and write down 2 radical 3. That's what it's going to be simplified. And when I multiply it times that 3, I'm going to get 6 radical 3. Does that make sense? So I'm going to have 6 radical 3, 5 radical 10, 2 radical 10, and negative 6 radical 2. So that's 6 radical 3. I'm going to have it 6 radical 3. This is 6 radical 3 instead. So I'm going to make my window panes. It's a binomial times a binomial. And I'm going to have 6 radical 3 up here, 5 radical 10. I'm going to have 2 radical 10 and negative 6 radical 2. It always helps me to write down the two things that you're multiplying. 6 radical 3 times 2 radical 10. The numbers outside get multiplied together. 6 times 2 is 12. The numbers inside get multiplied together. I get radical 30. That cannot be simplified. Top right. I'm going to take 5 radical 10 times 2 radical 10. 5 times 2 is 10. Radical 10 times radical 10 is 100. The square root of 100 is 10. 100. Lower right, 6 radical 3 times negative 6 radical 2. 6 times negative, I'm multiplying the numbers outside. 6 times negative 6 is negative 36. Numbers inside, 3 times 2, radical 6 can't be simplified. Bottom right, 5 radical 10 times negative 6 radical 2. 5 times negative 6 is negative 30. 10 times 2, 20, radical 20. But that radical 20 can be simplified. Negative 30, that's a negative 30, times, what's radical 20? 2 radical 5. So negative 30 times 2, negative 60, radical 5. So again, I don't have any like terms here. I have 12 radical 30 plus 100 minus 36 radical 6 and minus 60 radical 5. Again, in number 21, radical 5, and I'm going to change radical 8 to 2 radical 2. So minus 2 radical 2, radical 5 here, and negative 2 radical 2. Well, radical 5 times radical 5 is 5. Negative 2 radical 2 times radical 5 is negative 2 radical 10. Radical 5 times negative 2 radical 2 is negative 10 radical 10. Sorry, take that back. Negative 2 radical 10, there we go. And then negative 2 radical 2 times negative 2 radical 2. Numbers outside get multiplied. Negative 2 times negative 2 is positive 4. Radical 2 times radical 2 is 2, 8. Combine like terms. 5 plus, now you're adding the boxes here, right? 5 plus 8, 13. Negative 2 radical 10 minus 2 radical 10, they don't cancel. It's only going to cancel if one's positive and one's negative. This is negative 2 minus 2 is negative 4 radical 10. In number 22, when you solve radical equations, isolate the radical. The radical is already isolated. Square both sides. And when I say square both sides, put the right side in parentheses. I'll show you why in just a minute. Well, the radical and the squared cancel each other out. You're just left with x. It'll be equal to 7 squared is 49. Always do a double check. Check these out to make sure it works. Does the square root of 49 equal 7? And yes, it does. So that is your correct answer. In number 23, are there any numbers outside the radical on the left side, on that side? Any numbers outside that we need to clear away? No. Square both sides. Remember that the square cancels out the radical. You are left with x plus 1 equals 25. Subtracting 1 from both sides, you get x is equal to 24. Do a mental check here. Take 24 plus 1. That's 25. What's the square root of 25? 5. It checks out. In number 24, are there any numbers outside the radical that need to be taken to the other side of the equal sign? Yes, this 5. We need to subtract it from both sides. Radical 3x plus 1 is equal to 10. Whatever you do, do not do this. Do not try to square this, and square this. That will not work. Do not do that. What you'll do is you'll subtract 5 from both sides first to get the radical by itself. Then we can square both sides. Remembering, squaring both sides is the second thing on the list. 3x plus 1 is equal to 100. 3x is equal to 99. X is equal to 33. So what's 3 times 33? 99. Plus 1 is 100. The square root of 100 is 10. Plus 5, 15. It checks out. Page 4. Well, page 3. If you have radicals on both sides of the equal sign, immediately square both sides. And when I say square both sides, you'd better be using parentheses. Here's the reason why. You're going to have 5 radical 2x times 5 radical 2x. You're going to have 5 radical 5 times 5 radical 5. 5 times 5 is 25. Radical 2x times radical 2x is 2x. 5 times 5 is 25 times radical 5 times radical 5 is 5. 50x is equal to 125. When I divide both sides by 50, I'll get x is equal to 5 halves. Does that make sense? Yes, it does, because 2 times 5 halves would be 5. I'm looking at this right here. 2 times 5 halves would be 5. So you have 5 radical 5 is equal to 5 radical 5. Checks out. Number 26. When you have the radical isolated, there's nothing outside the radical, square both sides. And I say square both sides, I mean square both sides. Because the 2 and the squaring and the radical cancel each other out. You're left with x over 2 is equal to, now 3, 4. You don't just square the 3. You have to square the 3 and the 4. Now how are we going to cancel out divide by 2? We're going to multiply by 2. X is equal to 9 over 8. When you plug that, you can check this by plugging it into your calculator. 9 over 8 divided by 2, 9 over 16, the square root of that would be 3/4. It does check out. In number 27, we're going to have to subtract 10 from both sides first. Negative radical 2x is equal to 10. I do not have the radical isolated yet. I need to divide both sides by -1 so that I end up with radical 2x equals -10. Squaring both sides, I have to square the right side. I get 2x is equal to -10 squared 100, x equals 50. Well, take 2 times 50. What do you get? 100. What's the square root of 100? 10. What's 10? Oh, wait a minute. What's 10 minus 10? Well, it's certainly not 20, so this one's no solution. Evaluate 2 to the 8/4. Well, I can reduce that fraction. 8/4 is 2. So I have 2 squared. That's 4. 8 to the 1/3 power. This is actually the cube root of 8. 2. In number 30, because I'm getting that because remember, the numerator is going to be the exponent. The denominator is going to be the root. So in number 30, I'm looking for the 4th root of 9 to the 3rd. So now I need 4 factors that are the same underneath the radical in order to pull 1 out. So I'm looking at the 4th root of, all right, now 9 is equal to 3 times 3, right? Well, I've got 3 of them. I've got 3 9s underneath the radical. So I'm going to have a 3 times 3, 3 times 3, and 3 times 3. Now, I need 4 in order to pull out a single 3. I need 4 of those same factors to pull out 1. I don't have 4 remaining, so they get multiplied back together, and I'm talking about the 4th root of 9. Final answer. Find the distance between 2 points. Use your distance formula. The distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and take the square root of all of that. Make sure you leave the radical sign in there. That you have to have that square root. So I'm going to be taking 5 minus 5 and squaring it. Well, that's going to be 0, right? Plus, now I'm going to have -8 minus what? It's -8. Here's the minus sign. Now, what am I subtracting? -2 squared. Well, 5 minus 5 is 0. That's going to end up canceling out. We end up with the square root of -8 minus -2. That would be +2. -8 plus 2 is -6 squared 6. Because -6 quantity squared, that's positive 36. The square root of 36 is 6, right? Take your distance formula. and write it down. Or I tried to cheat there, I can't. No cheating on your test. D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I'm going to be taking the, now keep that square root in there. I'm warning you right now, some of you are going to want to drop it. You're going to have 3 minus 8 squared plus, then 4 minus 2 quantity squared. 3 minus 8, negative 5. Negative 5 squared is 25. So I'm going to have the square root of 25 plus 4 minus 2 is 2 squared is 4. We're talking about the square root of 29. If you're supposed to find that rounded off to the nearest tenth, square root of 29 is 5.4 rounded off to the nearest tenth. So if you need to find it rounded off to the nearest tenth, it's 5.5. It's a simplified radical. It'll be radical 29. You go ahead and do number 32. When you're done with it, come back. Pause the video right now, but go ahead and do number 32 on your own. And I just realized how long we've been on the air here, so let's wrap this up. I didn't realize that this is taking all this long. All right, so in number 33, we're going to multiply by radical p over radical p, and you get radical pw all over p. And number 34, these x's cancel, these y's cancel. The square root of 100 is 10. The square root of 49 is 7. In number 45, I'm going to take 45 divided by 30. I'm going to take 45 over 30 and reduce that. What do you get? Okay, so you get radical 3x over 2. We're going to have to multiply by radical 2 over radical 2, and you get radical 6x over 2. Good luck on your test. We'll talk to you in class. Study hard. See you then.